Yo, 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 this is Mr. O. Ah! Yo, 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 this is Mr. O. Hey, guys. And today we're going to learn about modeling quadratics. This time is velocity in terms of meters. In this case here, we're going to have a different equation because it's in terms of meters. It's adjusted to the terms of meters, which is negative 4.9 t squared. And the same thing with the initial velocity and the initial height. Again, let's have a review. Initial velocity is how you throw the object. When you throw it up, it's going to be positive. When you throw it down with force, it's negative. But when you just drop it, the initial velocity will just be zero. The initial height, it depends where the object was thrown. If you're in the ground, that's going to be zero. If you're above the ground, it will be positive. It's below the ground, it's going to be negative. Very simple, right? So a projectile is shot upward from the surface of Earth with an initial velocity of 147 meters per second. How high above the Earth does the projectile go? How many seconds is it in the air? So we're gonna draw as always. Since you're gonna shot it upward, is going to be the initial velocity will be positive. From the surface of Earth, that means it's on the ground with initial velocity of 147 meters per second. So, boom. And you are on the ground. Okay, so that's why you basically in the origin there. This is the y-axis. And the equation there with the initial velocity is 147 meters per seconds. So the function will be f of t is equal to negative 4.9 t squared plus 0 because you are on the ground. You don't have to write 0 there, but you may if you want to. And that's the function. How high above the Earth does the projectile go? So we're looking for the maximum or the vertex there. Vertex there will give us the maximum value or maximum height of the object. So we're gonna use for step 2, we're gonna find the axis of symmetry first, which is negative b over 2a. And in this case, negative 147 over 2 times a is negative 4.9. Using our calculator, negative 147 divide by parenthesis 2 times negative 4.9, enter. My answer will be in 15 seconds. So in 15 seconds, it will reach its maximum height. So now let's complete the vertex. We know that the vertex will have a 15 comma blank. How do we complete that one? We plug in 15 to the equation there. So it will be now f of 15 is equal to negative 4.9 15 squared plus 147 times 15 plus 0, which is, you don't have to write it down, negative 4.9, parenthesis, 15 squared, close, plus 147 times 15. My answer, or so f of 15 is equal to 1,102.5 meters. So therefore, the vertex here is 1102.5. So let's interpret this one here. How high above the Earth does a projectile go? How many seconds is it in the air? So how high above the Earth does the object or the projectile go? It went up for 1,000 or 1,102.5 meters high. How many seconds is it on the air? Now here's a portion. The answer is not 15. Remember, guys, it started on the ground or on the earth. So here, if it started on the earth, that will be 15 seconds before it reaches a maximum height. And then if that's 15 seconds on the same earth, on the same ground area, it goes down also with 15 seconds. How many do you think is the answer? How many seconds do you think it went through? If it goes up by 15 seconds, it goes down also in 15 seconds because they're the same object, same gravity, same surface. So the answer should be in 30 seconds. So in 30 seconds, it reached, no, in 30 seconds, it was all up in the air. Okay. Another way of proving that one, let's go with step four. This is another option for you, is to use quadratic formula or completing the square or factoring, by GCF, wherever you want. Okay. I'm going to use here quadratic formula. T is equal to negative 147, that's my B, plus or minus square root of B squared, 147 squared, minus 4. A is negative 4.9. C is 0 over 2 times negative 4.9. Since this one here is 0, 0 times 4, negative 4.9 times negative 4 will just be canceled. And since here it's squared, so you're gonna end up now with negative 147 plus or minus the square root of 147 squared. Squared and square root will cancel out. So therefore, you will only end up with, so that means you're gonna end up only with 147. So let's make this smaller here. Let's have a room. Okay. So that means now we have t equals negative 147 plus 147 over, this is 9.8, am I right? Okay, negative 9.8. And the other one is negative 147 minus 147 over negative 9.8. Obviously, this will give us a 0, negative 147 plus 47. So that will be t is equal to 0. Negative 147 minus 147, enter, divide by negative 9.8. The answer is 30 seconds. So what are the meaning of this? In 0 second, initially it's on the x-axis, it's the x-intercept. And after 30 seconds, 15, and another 15 here, it went down on the ground in 30 seconds. So that's also your x-intercept. All right, for our next problem, a ball is dropped from the top of a building 20 meters tall. How much time does it take for the ball to fall to the ground? So again, as always, let's start our work by make an illustration. So here's the ground, a ball dropped from the top of the building. So we have a building here, and the ball is right here on the top of the building. The building is 20 meters high. Since we know it's meters, we're going to use the function f of t is equal to negative 4.9 t squared. It has been dropped. So it was dropped, so there's no velocity. The velocity there is 0t. How much time does it take for the ball to hit the ground? Okay, so it's gonna fall that way. Since the initial height is 20 meters, I'm gonna put plus 20 here. And that is our function. Step two, we're gonna solve for the 0 here. We're gonna find for that x-intercept there. That's a 0. Okay, that will tell us the time when does the ball hit the ground. So you have several options in solving here. You can do quadratic formula, complete the square. But for this case, since my b here is 0, I'm gonna use taking square root. Okay, so negative 4.9 t squared plus 0t plus 20 is equal to 0. So the function there is equal to 0. So 0t is cancelled out. I'm going to move the 20 to the other side. So this becomes now negative 4.9 t squared is equal to negative 20. I will divide this by negative 4.9, divides by negative 4.9. This cross it out. So that will give me negative 20 divided by negative 4.9. That is around like 4.08 something. And whatever that value here, I'm going to, okay, so negative 20 divided by negative 4.9 will give me 4.08162653. There's a lot more. I'm not gonna cut it out. I'm gonna keep that one, use the memory of my calculator, and then take the square root, take the square root. So instead of clearing it, leave the screen on your calculator, just hit the second x squared or take the square root of second negative sign. That will give you the answer. And that will give me the time is the plus or minus 2.02, which we will accept the positive value, which is the time here is only 2.02 seconds. So means that the ball will hit the ground in 2.02 seconds after it was dropped. Okay. An object is launched at 19.6 meters per seconds from 58.8 meter of platform. When does the object strike the ground? What is the maximum height that the object reaches? When does it reach the height, that height? And where is the object at 2 seconds? Where is the object at 4 seconds? Where is the object at 5 seconds? So this is a good problem, okay? There are a lot of things that related here, okay? As always, we will make an illustration as our first step in solving this problem. So we have a platform here, and the height of the platform is 58.8 meters. Since that is meters, we're going to use f of t is equal to negative 4.9 t squared. And an object, let's say, it's going to go that way. Okay, there's a projectile motion. And the VO, the initial velocity, is 19.6 meters. Since it was launched, it's a positive velocity, 19.6 t. And the initial height is 58.8 meters. So this is our function. Number two, we're gonna find the zero here, this x value here, because the question here is when does the object strike the ground? So when does it hit the ground? So we're gonna get the x-intercept. We can use quadratic formula, factoring if it's factorable, copying the square and everything. And for this case, I'm gonna use quadratic formula, x equals negative 19.6 plus or minus square root of 19.6 squared minus 4 negative 9 and 58.8 all over 2 times negative 4.9. So x equal to negative 19.6 plus or minus. And from here, I'm going to use my calculator here. 19.6 squared minus parenthesis 4 times negative 4.9 times 58.8. That gives me a square root of 1536.64 all over, that should be negative 9.8. And when you simplify it, that gives you negative 19.6 plus or minus. The square root of 1536.64 is 39.2. Divide by 9.8 there. Now from here, we're going to split them into two. One will be x equal to negative 19.6 plus 39.2 over negative 9.8. And the other one is x equal to negative 19.6 minus 39.2 over negative 9.8. So let's see what's the answer here. So negative 19.6 plus 39.2, enter, divide by negative 9.8. That gives me negative 2. But again, we don't accept negative value here because it's time. So, but for the sake of answering, we have the answer there. Negative 19.6 minus 39.2. Enter, divide by negative 9.8. The answer is 6 seconds. So therefore, the object will hit the ground after 6 seconds. Okay, in 6 seconds it will hit the ground. Okay, so let's go to step number 3 here. What is the maximum height that the object reaches? So we're gonna find the vertex here. And for us to get the vertex, we have to find the axis of symmetry first using the formula t equals negative b over 2a. The b here is negative 19.6 over 2 times a is negative 4.9. So let's see here, negative 19.6 divided by negative 9.8. That will be at 2 seconds. So the vertex here will have 2 comma blank. We're going to plug in the 2 back to the problem. F of 2 is equal to negative 4.9, 2 squared, plus 19.6 times 2, plus 58.8. F of 2 then will be equal to um, negative 4.9, parenthesis 2 close squared, plus 19.6 parenthesis 2 plus 58.8. That will be 78.4. So therefore, comma, this is 78.4. So that's the vertex. So what's the meaning of that one? What is the maximum height that the object reaches? The maximum height the object reaches here is 78.4 meters. When does it reach the height? Uh, in 2 seconds. Okay. Where is the object at 2 seconds? So in 2 seconds, it's already at 78.4, which happened to be the vertex. So that's the answer to this. Where is the object at 4 seconds? So basically, you're gonna plug in f of 4 to the equation because we're looking the height of the object in 4 seconds. So we're gonna plug in negative 4.9, 4 squared, plus 19.6 times 4 plus 58.8, and negative 4.9 parenthesis 4 squared plus 19.6 times 4 plus 58.8, enter. And the answer for f of 4 or at 4 seconds will be 58.8 meters. Where's the object at 5 seconds? So I'm going to do the same thing, but this time I'm going to look for f of 5. So negative 4.9, 5 squared, plus 19.65 plus 58.8. It's going to be at 34.3 meters, which is reasonable because if we look at the illustration, in 2 seconds it reaches the maximum height. So at 4 seconds and 5 seconds, it should be going down. So in 4 seconds it was 58.8 meters. In 5 seconds it will be 34.3, and at 6 seconds it should be on the 0 feet already, or 0 meters already. It should be on the ground. Okay, and that's how you solve